Hello and welcome to David's math class. In this episode I will show you how to derive the volume of a pyramid with any base. So, we start off with the simplest case, a pyramid in a cube. So, we'll draw out our cube like this. Alright, that's a cube. And then notice we could fit a pyramid like this into the cube. So that's it. That's that. Now, for our second pyramid, we will do this. And then our third pyramid, what's left? So this, great. So notice how the yellow plus the green plus the red pyramid give us the volume of the cube. But when you consider the fact that each one has the same base and the same height, in other words, actually they are identical, and I'll just draw them out for you. So something like this would be the first pyramid. This is a straight line. The second pyramid will be the same. You can see it just rotated like that. Wait, let me actually draw them out in perspective for you. So, you will roughly have something like this for the first one, then this for the second one, yes, I made it abnormally tall, so I just redo this. So you have a square and then this, and for the third one you have a rhombus, and then this, and this. So notice the base is the same. It's always a square with the same length. And the height is the length of the cube. So that means that these three pyramids are actually equal in volume. So what that gives us is the volume of a pyramid is equal to the volume of a cube over 3. Now, this volume is equal to the base of the cube, base times the height of the cube, which is h, which is really just the length of the cube over 3. And now, this formula will hold even if we scale the cube because really what happens is we scale either by the height or by one of the lengths of the base of the pyramid, and if we scale any length, we will just multiply this here. The base will stay the same, the height will stay the same, the volume just really stretches out with the lengths. So this is true for all rectangular, let me just write this, so rectangular prisms. Now, one more thing we have to consider is what if we move the peak of the pyramid, what we'll end up with is something like this. And really, because we could slice up this pyramid into many sections, and we could move those sections, like just slide them, and we would get the same volume for the pyramid, but we just change the pyramid shape. Really, the volume of this is equal to the volume of this. So the volume stays constant even if the upper vertex gets moved around. Great. So now we have prisms where the vertex at the top is anywhere. Alright. Now, what happens if we have another base? Well, let me just draw this out for you. So we don't have a square base, we have or a rectangular base, we have a squiggly shape. So consider a rectangular shape, and I just, for the sake of reasoning, take the vertex to be at the above the center of the rectangle, and then we have a squiggly shape like this with its center right here, and we take its volume. So we could slice up this pyramid And if these two shapes have the same area, we could slice up this as well. And now we just focus on slicing infinitely many times. So infinite slices. And really, if those two shapes have the same base area, no matter how we obtain that area, really our slices would be prisms, like prisms with very, very small height, but with a different shape. And since the height is the same, the base area is the same, and the volume is always base times height, really each slice, each corresponding slice is equal in both the pyramids. So what that means is, if the base of a rectangular base is equal to the squiggly base, like this, then the volume of the pyramid is always base times height over 3. And really we have verified every single case. So square pyramid, rectangular pyramid, vertex at the top anywhere, and then any base. So really this is the formula for, I'll do it in black. This is the formula for the volume of a pyramid. Thanks for watching, and see you in the next math class.